Hi grade 9s. Today we are going to do a lesson on like terms with algebra tiles. We're going to do this with algebra tiles today, and then next class we're going to do the same thing without algebra tiles. So when we are working with the same algebra tiles and we're doing like terms, here's what we're going to do. What we're going to do, first thing we're going to do is we're going to group all the same shapes together. So what kind of shapes do we have? We're going to have big squares, we're going to have rectangles, and we're going to have little squares. So we're going to put all the big squares together, all the rectangles together, and all the little squares together. And then we're going to remove zero pairs. And we're going to talk a little bit more about that in just a second. Then we're going to write the remaining shapes, and we're going to not only show what they are as a picture, we're also going to write them out as a polynomial. Okay? But before we do that, let's talk about what is a zero pair. A zero pair is when you have two different colors of the same shape. For example, if you have a big green rectangle and a big white rectangle, basically what that means is you have a positive x squared and a negative x squared, and as we know, positive 1 and negative 1 adds to give you 0. So that's why it's a zero pair. If you add them together, you get 0. The same is true with the rectangles. A green rectangle is positive x. A white rectangle is negative x. Add those together and you're going to get 0. Last but not least, if we have a small red square, that's positive 1. If you have a small white square, that's negative 1. You add those two friends together and again you get 0. So if we have, the understanding is that what we're going to be doing when we talk about algebra tiles is you're going to have to show your work. And when you show your work, I'm not going to give you all green and red pencil crayons. So we need to find a better way of doing this when we're showing our work. So when we have a green rectangle, a positive rectangle, positive square, my bad, positive square, we're going to make sure that we just shade it in. Doesn't have to be green, you can just shade that in. Okay? Then, what we're going to do is we're going to look at what we do when we have a positive rectangle. A positive rectangle looks like this, and we're just going to shade it in. We're going to shade in our positive algebra tiles. So the same is true when we have a red square, which is a positive 1. We're just going to shade that in like that. So whenever you have a positive algebra tile, a positive big square, a positive rectangle, or a positive little square, we're just going to shade those in. Okay, we don't have to color them, we just have to shade them in. That'll distinguish positive tiles from negative tiles. Okay? When we talked about fractions before, we talked about putting things in simplest form. A polynomial is in simplified form when it can be drawn using the fewest number of algebra tiles possible. So just remember, and here it just reminds us that the big green square is positive x squared, the big white square is negative x squared, the big rectangle, just the rectangle that's green is positive x, the white rectangle is negative x, a red little square is positive 1, and a little white square is negative 1. And again, we can't denote the green and the red, so we're just going to say that we shade in those positive tiles. So, example, simplify the polynomial pictured below, write your answer in symbolic form. So what we really need to do here is we need to rewrite this out with all the like stuff together. So I'm going to cheat a little bit here. You can't do this, but I can. I'm going to take all this stuff and I'm going to clone it. And I'm going to make a copy of it. I'm going to put it over here. And what we're going to do here is we're going to take these two rectangles and we're going to combine it with this other rectangle. Then we're going to take these little red squares rather. I don't know how I thought they were white. Those are little red squares. And we're going to combine them with these little red squares. And now all of our rectangles are together and all of our squares are together. And then what we have to do is we have to take a look at this and we have to say, okay, are there any zero pairs? In other words, do I have a positive and a negative in each of the shapes? So we'll start off with the rectangles. There's a green rectangle and a white rectangle. So this is a zero pair. So they cancel each other out. There's only one rectangle left, so you can't make a pair out of one. So there's just the one rectangle left. And we also have our little red squares. Now they're all little red squares. So because they're all little red squares, that means there's no zero pairs, so that's all we have. This question does not tell us what letter we're using. The universal variable in math is x. So what we could say is we have just this one rectangle, and we also have these 8 squares. Again, I know you don't have red pencil crayons more than likely, so the rectangle should be blank. It shouldn't be shaded at all, but the little squares should be shaded. So all the little squares need to be shaded. And let's say we're using the universal variable x in this case. So the rectangle would be negative x, negative because it's unshaded. And then we have 8 little shaded squares, so that's just going to be plus 8. And this is your final answer. So when we simplify this, we get negative x plus 8. If you use a different letter other than x, that's okay. You don't have to use x. You can use x if you want. You can use j if you want. It doesn't matter which letter of the alphabet you use. Alright? Okie doke. Next example. Simplify the polynomial pictured below. Write your answer in symbolic form. This is the exact same question as the one above. Except in this case, instead of rectangles and little squares, we have big squares and little squares. The way we're going to treat it is the exact same. Which means that, again, I'm going to cheat a little bit here. I'm going to just take my fancy program here, and I'm going to clone this stuff to make my life easier. So I am going to kind of at least somewhat be okay here. I'm going to put it all down here. I'm going to bring up the big squares, because the big squares are going to go together. I'm going to combine it with this big square, so put that big square right there. Then I'm going to put these little squares up here. And I'm going to put these little squares beside the red little squares. It goes without saying that when you do these questions, you have to show your work. And you might ask or think or wonder, how much work should I show? Here's the easy answer. If I'm showing the work on my page, this is what I expect that you need to show. So please make sure to show your work. The first step is put all the like stuff together. Put the big squares together and the little squares together. Then, after you do that, it's all about finding those zero pairs. So, let's look for those zero pairs. I have a negative and a positive big square, so these two cross each other out. Bye-bye, gonzo, history, see you later. And as far as the little squares go, there's actually going to be a number of zero pairs. As a matter of fact, we could say that this red square cancels out with this white square. This red square cancels out with this white square. Then we still have 2 more red squares, so we can cancel them out at the same time as long as we cancel them out with 2 white ones. So here's the white ones, they go as well. So after we do that, all we have left are white little white squares. And how many little white squares are we left with? Well, our job is to then on the next line say what we've got left. So we've got 2 big green squares. There they are. And we have 5 little white squares. Again, I don't really care what letters we use to represent the variable. We used x last time. Let's use y this time. So there's 2y squared. That's for your 2 big green squares. And then we have 5 unshaded little squares. So that's minus 5. That's what that would be when we simplify it into its simplest terms. Moving on, now we're going to simplify the polynomial picture below, write it in symbolic form. Here we've got big squares, here we've got rectangles, and here we have little squares. We have a little bit of everything here. So when we rewrite this, of course, the first thing is that we want to put everything together. We want to put the big squares together, we want to put the rectangles together, and we want to put the little squares together. So there's a big square. There's a big square. There's some rectangles. There's the rest of the rectangles. And then we have these little squares. So we put them all together, and then we'll see what 0 pairs we can make. So for the big squares, we can make 1 0 pair. This green square cancels out with this white square. Then we have, how many 0 pairs can we make with the rectangles? Well, there's 4 white rectangles and 6 green rectangles, so we can make 4 of them. Here's a 0 pair. That's a 0 pair. That's a 0 pair. And that's a 0 pair. And we're left with 2 green rectangles. As far as the little squares, interestingly enough, we get 1 0 pair here, 1 0 pair here, 1 0 pair here, and there's none left. So if we write out what we have left, we have, oops, didn't mean to do that, don't want to take it. There you go. We have 2 big white squares, and we have 2 green rectangles. We used x last time, then y. Let's use z this time. So we have 2 big unshaded rectangles, so that's negative 2z squared plus 2z, and that's what it would be. Negative 2z squared plus 2z. Okay? And the next question doesn't give us a picture. It gives it to us in symbols. But it does ask us to do this with algebra tiles. So how are we going to do this with algebra tiles? Well, we're going to draw it out. And I'm not going to cheat anymore. I'm going to write it out exactly how I'd like you to write it out. So 2p would be 2 positive or shaded rectangles. 3 would be 3 shaded little squares. Negative p is a blank or unshaded rectangle. 1 is a shaded little square. And then minus 4p would be 4 unshaded rectangles. Again, if they're negative, they're unshaded. If they're positive, they're shaded. And now what we're going to do is we're going to put all the rectangles together and all the squares together. So put our 2 positive rectangles together with our 1, 2, 3, 4, 5 unshaded rectangles. And then we have our 1, 2, 3 shaded little squares that we combine with the other shaded little square. So, what 0 pairs can we make? We can make a 0 pair right here and a 0 pair with these two. And that leaves us with three unshaded rectangles and 4 shaded little squares. And in this case, it does matter what letter or variable we use because it gave us one at the beginning, and the variable it asks us to use is p. So our answer must be using the variable p. So it's going to be negative 3p plus 4. Negative 3p plus 4. And that's the answer. Okay? So when we find the answer in symbols, or rather in shapes, we have to convert it back to symbols and letters and algebra, and that's when we write out it's negative 3p plus 4. Okay? All right. With that, we have one final example. Here we go. Again, it gives it to us in algebra speak. We need to translate it to pictures and then do all the stuff we've done so far today. So we're going to simplify using algebra tiles. So we're going to write out what g squared looks like. That is a big shaded square. Then minus 3g is 3 unshaded rectangles. Then it's plus g squared, so that's another shaded big square. Then we have plus 4, which is 4 shaded little squares. And then it's minus 7, so that's 7 unshaded little squares. And then it's minus 2g, so it's 2 unshaded rectangles. So that's how we draw it out. After we draw it out, then we put all the like stuff together. So we're going to put our big squares together. So we're going to have 2 big shaded squares. Those are the only shaded squares we have. Then we have a total of 5 unshaded rectangles, and there's no 0 pairs here either because they're all the same color. The big squares were both shaded. All the rectangles are all unshaded. But there are going to be some 0 pairs when it comes to our little squares because we have 4 shaded little squares that are going to get combined with 7 unshaded little squares. And so when we go to find the 0 pairs, there's a 0 pair, there's a 0 pair, that's a 0 pair with one of those, that's a 0 pair with one of those, and we're left with 3 unshaded little squares. So we'll finish up by showing that we have 2 shaded big squares, and we have 5 unshaded rectangles, along with 3 unshaded little squares. The variable in this question is g, so it's going to be 2g squared minus 5g take away 3, and that's what we need to do. So if it gives you the equation or the expression like it does in this question, you have to draw it out. You have to draw it out again and put all the like terms together. Use your 0 pairs to eliminate stuff that makes 0. Write out what's still left over, and then translate that back into an algebraic statement or a polynomial. Your homework will be handed out to you right now.